Hello everyone, Ismail is here. Today we're going to complete Unit 2, which is with the last lesson, 2.3. 2.3 talking about solving absolute value inequality. You can find the lesson using my website. Okay, now here is the warm-up question. Try to do it. If you have a question or anything, just contact me. Now, let's start with our lesson. Now, our lesson, let's take a small introduction about, if you remember, the two solution, okay, and one solution. Okay, and there is no solution. Do you remember this from the previous lesson? Yes. Okay, now let's graph this function. Okay, let's graph this function. Then after that, we will check what is the solution for this function here. Okay, now first, I told you before, we just imagine that the left side is a function, which is a score is y1, and on the right side is the other function, which is y equal 2. Okay, now let's graph the first function, which is y1, which is equal absolute value x plus 3 plus 1. Okay, then after that, we are going to graph y2, which is equal 4. Now, let's graph both of them to understand. Now, if I need to graph this absolute value, I need to identify first h and k. So h and k here is equal, always opposite h, same k. So it will be negative 3 and 1. Then let's identify the slope. So the slope here, a is not given. So always when a is not given, always a is 1 over 1. Now let's graph this. So negative 3 and 1. If this one negative 1, this one negative 3, and 1. This one is 1. So we put the first coordinate here. Then it's say 1 up, 1 to the right, 1 to the left. So should be here. 1 up, 1 to the right, 1 to the left. Then you can connect between your 2 points and you will get this graph here. Okay. Now, after we graphed my function, now let me graph the y equal 4. Now, y equal 4 is here, right? Okay, so y is equal 4, just put straight line. And now we have two solution. So the first solution here, what's the coordinate? So the first one is negative 6 and 4. So negative 6 and 4. Okay, the second coordinate is 0 and 4. So as you can see here, we have two solutions, which is these two solutions. Now, let's answer the question here. So the graph of f of x equal x, absolute value of x plus 3 plus 1. So above the graph of what? Of g of x to the left, okay, which is negative 6, to the right, which is x equal 2. Now the solution, now if you look now to my solution, let's start from negative 6, okay? And, or let's say, let's start, let's say, because we know, if you remember the domain, always the domain, we start from left to right. So let's keep it on this. So my x's, the first x is equal negative 6. My second x, which is equal 0. Okay, so now as you can see here, the first x from the left, which is x negative 6, and from the right, x equal 0. Now the solution of this one, so the solution of this one is what? It's very clear to you. So the solution for this one, let me show you the answer here, is negative 6 and 0. Okay, now let's focus on the inequality. So, teacher, why the inequality is like this? Now, understand. Look to this one. Here, it's saying in the question, this sign means my function is what? My function, which is y1, is greater than y2. Is that right? So, y1 greater than y2. If you look here now to the graph, okay, so this is my 2 point, okay, and now this one is my graph, and this one is my other graph. So we need to check if my graph, is it greater than this one or less than this one? Now, let's check the answer here. Okay, now let me remove this. Okay, let me remove that. Okay, so now check this. So my graph, it's saying my graph, which is y1, is greater than y2. So greater. So if this one 4, okay, and if we go up, all the value up are what? Are greater. Okay? All the value in the down, or let's say in the below, are smaller. So because the question said my function is greater. So my function is greater than -4. So my graph should always be above number 4. Let's take another example to more explain this. Okay, now let's do the same step. So we consider this one as y1, okay? And which is y1 equal absolute value x minus 2 minus 3, okay? And let's do this one is y2. So y2 is equal 1. Now let's graph the first one. So to graph it, we need to identify h and k, which is 2 and -3. Okay, then a is not given, so a is equal 1 over. Now 2 and -3. So this is 2, this is -3, should be here. Okay, one up, one right, one up, one to the left. Then you can connect your graph and it will look like this. Same thing if it will go like this. Okay, now if we need to graph y1, okay, so where is y1? Y1 is here. Okay, so y1 is here. Let me just fix my first graph. So my first graph will look much better than this one, maybe. Okay, so now if I fix my graph, okay, so this is my point. So now let me connect it straight to here and straight to here. Okay, then now let's graph y2. Okay, y2, which is connected here. So as you can see here, this one is y equal 1. Okay, and this is the first point. So the first point now is if I tell you the first solution is -2 and 1, which is this one is my first x. Okay, now the second x, which is the coordinate here, 6 and 1. So my second x is equal 6. Now, as you can see, the first one, we need to write x2 and x6. Okay, so we have x2 and x6. So now what type of inequality I'm going to use here or here? So now, first of all, you need to think about that. Think about this. Here it's saying, look now to the inequality in the question. Is the inequality in the question, it's saying, is the question greater than or less than? It's saying less than, because less than, that's mean we going down, which is less than. So we are talking about this graph from here to here. So now from here to here. So now if I need to put the inequality, so it's saying all the x here the x is greater or less. It's less than 2. Okay, and here same thing, x less than 6. So now if you look now to the inequality, both inequality have same thing. So how can I compare this one? So you know that you can add these two together at one inequality to become from 2 to 6 and x in the middle, and you put the same inequality. So this is how you can write the inequality when you have inequality similar to each side. Okay, you can combine them together. Okay, another example like this one here. Okay, now let's solve this one. So to solve this one, so this one is y1. Okay, y1 equal absolute value x plus 1, absolute value of -4. Okay, so now let's graph this one, h and k. So h and k here is -1 and -4, right? A is not given, so that's mean a is 1 over 1. Now the first point, -1, which is this one, -1, -4, so my point should be here. Then one up, one to the right, so one up to the right, one up to the left. Then now you can connect your graph and it will look like this one here. And from the other side, it will look like this one here. Now, let's graph the second coordinate, which is -2. So -2 is y2. Okay, so this one is y2. So -2, where is -2? This one is -2. So now you can put your line, which is -2 here. So now, as you can see, we have two solutions. Okay, so the first coordinate, it's -3 and -2 because this one is -3. So this one is my first x. Okay, now the second x, which is this coordinate here, is 1 and -2. Because this one is 1, so this is my second x. Now, let's have a look on the inequality here. So the inequality here, it's saying y2, okay, is greater than, or let's let's put it in the other side. So let's say y1 is less than or equal y2, right? Okay. Now, if you see here, because it's saying less than, so we are talking at this type of function, which is this one here. So that's mean if we look now, the first x is -3. So -3 is greater than x, and on the other side here, 1, which is 1 is greater than x, and we put the equal sign because the question give me the equal. Now, as you see here, the inequality are same. They have same inequalities. The inequality is same to this one. So you can combine them together. So -3, then less than or equal x, less than or equal 1. So this one is my inequality. Okay, I hope this is clear for you. Now, it's your turn. Try to solve or to graph this inequality and to find the solution for each one. Now, let's go to the solving absolute value inequality algebraically. Okay? So, first of all, what we need to, number one is when you need to have a look on this. This is very important. Now, how we can do this one algebraically. In the previous questions, all the questions was we're doing them graphically. Here, we are going to do them algebraically. So how we can do them algebraically? First of all, absolute value of x. When your function, let's say this is y1, this is y2. So when you have y1 is greater than y2, okay, then your inequality will look like this. Okay. Always your inequality, if you look here, they will be different. They will not be equal. Okay. So that's the first one. Now, the second one, number two, if your inequality, okay, if your function is less than y2, which is y2 is greater than y1, so your inequality, you can combine them together to become like this. So isolate the absolute value expression as we would any equation inequality, then follow the rules above. Okay. Now let's take an example. So as you can see here, okay, if x any real number and not just an integer graph, so the solution of this one. So this one is easy. As you can see here, we can use this one to find the answer. So as you can see here, it's saying -3, and here's the 3. So you can put your range, it will be like this. And because it's open circle, we are going to use this one. Okay, for this one below here, as you can see here, we have -3, and here you have a 3. But you can't combine them together because each number, it goes to either side. They are not going to the same side. So that's mean here it's saying this is x, right, which is infinite. So we always write from -infinite to -3, right? So this is as inequality. So if I need to write this one as range or the domain, so remember, we don't write infinite. We write x, okay, less than -3, okay? Or we can write or 3, okay, or let me write it in the other side, okay? So if I write this one as in table notation, so it should be from 3 to positive infinite, right? so to positive infinity. So if I need to write this one, it will be x greater than 3. So now this is my domain, or this is how can I represent this. Okay. Now let's start with solving inequality, as you can see here. Okay. First step First step, we need to simplify the equation until we get this side. We need to make absolute value of something greater than or equal another number. So you need to simplify. So you need to work this one as normal equation. So first step, let's isolate this one in one side. So let's isolate the whole absolute value on one side. So how can I isolate it? So first we minus 15 from both sides. So it will be absolute value 4 minus x, okay, greater than 21. Okay, 21 minus 15 equal 6. Sorry. Okay, 21 minus 16, minus 15 equal 6. Now, you have your inequality on the side and you have a number on the other side, right? So now you have y1 and you have y2. So now check. So is this one following the rule number one or it's following rule number two? Okay. So if we look to the rule number one, it's saying my function is greater than a. Yes. So my function here is greater than a. So my range should be written, or domain should be written like this. So now let's do the same thing. So let's take them on the right side, on the left side. So now let's remove the absolute value. Okay, 4 minus x, okay, less than negative 6, and 4 minus x, which is greater than 6. Okay, so we do the same. Now, let's simplify this one. So to simplify this one, we need to, let's say, minus 4. So we cancel this 2, so negative x less than minus 6 minus 4 equal minus 10. So, and here, same, we do the same thing, minus 4 minus 4. Okay, so this one we cancel, so negative x is greater than 6 minus 4 equal 2. Now, because here we have a negative, okay, because we have negative x, so we don't use negative. Negative, give you an example. So when we have negative x means negative 1x. So let's say negative y means negative 1y. So always the negative sign alone represent negative 1. So now how can I change the negative 1 here? So to change the negative 1, okay, remove negative 1. So let's divide by both sides by negative 1. So we cancel this 2. So it means x, okay, and here negative with negative will become positive. And on the other side here, we do the same thing. This one is negative 1. So divide by negative 1, divide by negative 1. Then we cancel 1, negative 1 with negative 1. So it's remain x, 2 over negative 1, which is negative 2. Now, you will ask me, teacher, why you didn't try the inequality? Always, always, always. When you have example, negative x greater than, let's say, 2 or 3 or whatever, and you need to divide by negative 1, always when you divide by negative sign, always, okay, what you need to do, you don't keep your inequality at the same. When you divide by negative, you write it x and you flip your inequality, okay, and you write the answer, okay. So always when you have an inequality, you flip your inequality there. Like, let me give you another example. So let's say we have negative x greater than 5, okay, or negative 5. So here we have negative 1, right? Here we have negative 1. So negative 1 divide by negative 1. So you cancel negative with negative x. Now flip this one to the other side. Negative 5 over negative 1, which is equal 5. So same thing do here. So because we divided by negative 1, so we need to flip this one here. And as you can see, divide by negative 1, divide by negative sign. So you need to flip this one here. Now, let's graph this inequality. So to graph this inequality, always x here first at 10. The second one is negative 2. So 10 is here. Okay, so not closed circle, it's open circle. Why it's open? Because the inequality here not with equal. So 10, and -2 here. So we have here -2 and we have 10 here. Now, what you need to do, always, always look to the back of your inequality. So your back, it goes to this side, right? So your function will go to this side. Look to the back of this one here. So it goes there. So your function will go like this. So always look to the back of your inequality. The back of the inequality will lead you to the correct answer. That's it. Okay, let's take another example. Okay, let's hurry up because I have a class. Now, how about this one? So let's add 10. Okay, add 10. We solve it normally. Then we have x plus 4. Okay, cancel this two. Less than or greater, less than or equal, positive a. Okay, so now we are at the second situation, which is a is greater than the inequality. So let's take them on the two side like this. Okay, so x plus 4. Okay, x plus 4. Oh, sorry. Sorry. We are in the second. We are in the second. So we're going to use this one. So two, we will not have two sides here. We're going to have only one side. So let's write this one. So it will become here. So 8, it will be here and here. Okay. And your function will be like this. And the inequality will be in the middle, x plus 4. Okay, so now what we need to do, sorry, here it's negative. Okay, so now what we need to do, we need to simplify the equation in the middle. We need to leave x alone. So how can I isolate x? So -4 for all side, -4, -4, -4. So -8 with -4 is equal -12, less than or greater x, let's cancel each other, less than or equal 8 minus 4, which is equal 4. Now let's graph this absolute value. So the first x is -12, so -12 here, and it's close because it's equal, greater than or equal, or less than or equal, and here is 4, which is 4 is here, same thing. Now look to the inequality. So your inequality, it's saying go to this side. So you have to go on this side. Or just just to tell you an example, when you look to this inequality here, okay, and you have number and x in the middle and the other number, always your graph will be between these 2 points. Always will be like this. Okay, clear? Okay, last example, let's take this one. So as you can see here, we have no adding or subtracting, we have to divide. So we divide 3, we cancel this, then x minus 7, absolute value greater than or equal 9 over 3, which is equal to 3. So now we are following, if we go back here, we are following this situation, which is my function greater. So I should have this one, x, okay? So I should have this one, which is x minus 7, okay? And here, x minus 7. So let's go back here. So less than -a, greater than a, okay? So now let's go here. So it will be less than -3 or equal, because here it's equal, okay? And here greater than or equal 3. Now solve this inequality very easy. So we plus 7. Okay, so we cancel this to x is less than or equal -3 with 7, which is equal to 4. Or we can just write or in the middle, then plus 7 plus 7. So we cancel this to x is greater than or equal 3 plus 7 equal 10. So now let's plot this one on a graph. So 4, it's here and it's closed because it's equal. 10 is here because close it's equal. Now how you can know where you should go? Now look to the inequality. Here from the 4, go to the left. So from 4, go to the left. Okay? 4, go to the left. On to the right, go on the 10, go to the right. So it will always like this. Okay, clear? I hope this one is clear. You have here another example. If you look, it's similar thing. So just follow it easy. Then you can graph it. Then it's your turn. I hope this lesson is understandable. It's a little bit confused. but it's easy if you understand, if you study and practice. Thank you. Have a good day. See you. Bye bye.